So, all right. Hi, everybody. Thank you so much for coming to this week's Retrieval Market Demo Days. Looks like we have 3 presentations today. We have FilSwan, Ken Labs, and PegaSys. Please remember, for anyone who has any questions, to please ask them in the Slack channels. That way they can be answered async. So anyone who's not watching this recording live can be able to see the questions and understand them as well. And then after this recording, I'll be posting it to the Google Drive if anyone wants to go back and take a look at any of the key sections. So first off, it looks like we have someone presenting about FilSwan. I'm not sure who it is because there's no name next to the title. So I'll let whoever it is take over and start sharing their screen.
Charles.
Okay.
We cannot hear you.
Sorry.
There we go.
I just share my screen. Hope everybody can see it. Yes, this is the part 2 of the background. So part 1 is about how to send out a deal and backup to the Filecoin network from the command line tools we showed last time. This time we go to the even more complicated part. It is designed for the UI part. So you can click the button and share the deal. So because it's a little bit complicated and we just get it running on local machine, so we would make a push request. So let's see how it works. Yeah. So basically, with current settings, you can easily set up the video with running a miner locally. So after that, you'll be able to connect to a remote miner servers, and after you log in, after log in, you'll be able to see you have a file uploaded. Yeah. After that, we have a fancy button, which is at the right corner. You'll be able to upload it through the UI. You can see the uploading progress. Yeah, as long as it shows up, you can click the button to add the icon share to Filecoin network. You can put the miner ID you want. Set up the price you want to give them per epoch. And you set duration, how many days you want to save on the Filecoin network. Then you click send. Then you will get the DLC ID, which means that you generated the transaction. After that, if you look at through the deal list, you will find that at the backend, the deal is sent out. And then you'll be able to, the miner side, you'll be able to get the data from online transactions. So to give people really AWS compatible values, so which is great for them. And we're still working on some tiny issue we want to fix about the credentials, the security side. We're still doing the optimization about it, but this is first work we have done. And the interesting part is that the original, we also did push all the result with code we already have to the repository about a few minutes ago. And the interesting part in the browser part, we're also doing a modification. Previously, the browser was using the React.js, but we developed another version, Vue compatible version. So basically, we rewrite all the UI stuff using the Vue and using the new command to doing the build. Then but we still need to polishing all the results to make it much better. So I think next week we can get a full document for the team who want to running the miner service as an independent library, so they can reuse it and integrate it into their platform. Yeah, this is just a short demo by us. Thank you, everyone.
Awesome. Thank you so much, Charles. All right, so remember, if you want to ask any questions, feel free to ask them in the Slack channel. David put it down there, but it is the Retrieval Market Builders Slack channel specifically for anyone that has any questions. So now we have Ken Labs, and they will be discussing a new indexing tool, it looks like.
Hey guys, this is William. Can you hear me?
Yep.
Cool. So this is the first time to present here. So let me share my screen. Sorry, Luke, I need to unlock the security and the privacy.
If you're on a Mac, you're gonna have to do that, and then you have to restart Zoom to make it work. It's frustrating.
Oh yeah, I need to.
Gotta love having to deal with Zoom security settings all the time, right?
Yeah, every
Hey,
time
guys.
there's an update. Welcome
Um,
back.
There we go.
Back. Sorry for waiting. Now I hope you can see my screen now.
We can.
Cool. So I prepare a simple slides here. Okay. Let me start. So I'm William from the Ken Labs. So today I'm going to present the IPFS indexing tool. So this is the agenda. So I'm going to talk about the objectives, architecture, and demo a bit in our test server. Then I'll show you the future plan. First of all, the objectives. So in this demo, I'm going to show you the tool, a simple tool or solution. This is to allow ingestion or import files into the IPFS node while there's no data duplication happens. So some words on this duplication. So when you add some file to the node, apparently when you create a block, it contains the bytes from the file content. So in some user cases, so with the massive data collection, you may not expect the data duplication. Instead, so we just save the metadata of the file into the blocks, so it can save huge amount of storage space. So this is especially useful, as I just mentioned, when the user has a large data set. So this is a simple architecture overview. So you can see we have a IPFS node. And sorry, 1 second, how can I remove this guy, this bar? Okay. Okay, so we have an IPFS node. And this is a general architecture. We have an IPFS-sync process, which will watch a directory or folder in the file system. With any file change, including new file or file update or file deletion, so it will sync the change by adding the files to IPFS node. Here we use the IPFS file store, which is an experimental feature. So in this way, we don't store the raw data, the raw bytes of the file content. Instead, we just have the metadata in each block generated by the IPFS. So it saves space. So this is how we watch the directory and sync to IPFS node. At the same time, with any change synchronized to the IPFS node, the IPFS-sync process will receive a CID, which is a root node of the DAG. So we push the CID and the local file path, the pair, to the time rows backend, which is our own developed backend. So this pair is stored in our database. Also, this backend serves the front end. Sorry, I need to remove the port here. So we just switch to 80 port. So this is the front end IP address. So this is the very generic architecture. Okay, so as I mentioned, so we we are using the Go file store, the feature in this solution. And more specifically, we use a no copy option that allows the IPFS just store the metadata of the block, including file size, offset, and the path, the file path. So in reading scenarios, it will fetch the actual bytes from the original file or the file in the local file system. So it will also still work in the most of the IPFS interface, including the command line and the HTTP. So this module is, so the IPFS-sync module is also an existing project or module. Yeah, we did some enhancement. So in the watch process, we notify the time rows backend with the file change, as I just described in the architecture overview. So all those CID to the file path mapping is indexed by time rows backend. So in this way, we know what files have been synchronized and what the CID is. So the root node. So this is the architecture. So I show you some demo in a test server. So in general, I'll connect to the server and copy some files to the watch directory. Before that, I'm going to launch an IPFS-sync process with a customized configuration. In this way, I'll just customize to some specific directory. So I'll show you that soon. And then we refresh the file store page on time rows front end. We will see the status. And I will show you more on the front page, including the lag overview. Okay, this is from the slides. Okay, let me go to the server. I have already logged into the server, and this is the time rows front end. So we conform to the web UI component, so it's pretty similar UI. So you will be very familiar with it. Now I'm going to, first of all, let me show you here. This is the IPFS-sync binary we built, and I can use this startup script to launch a process, something like this, and specify, say, I create a test set folder here, and this is a Boolean option for no copy. True means we use no copy. Okay, it's starting to watch this folder, and let me show you the process. So there are two IPFS-sync process, which one is running as no copy false. So it will copy the actual file content, the bytes. So this is the process that we have been running for a while. So this one is I just launched with no copy true. And here I'm taking the log. So let's see. And first step, let me add so I prepared two files. So due to the limitation, I cannot prepare two large files for this demo. So I prepared two. One is somehow smaller. So let me move this file. So you can see, let me move this file to root test set. And let's go to here. Yeah, this is the file I just added. So it's Java language specification, if I remember, PDF. So this is a PDF file I just added. So you can see the file size, and so you may wonder what are these two menus files is the one we built for the actual files we add to the IPFS node. So all the blocks have the bytes, the original content bytes. So we won't cover it today. So file indexes, this is what I'm talking about. So the files I added with no copy option. Okay, so let me click this file. So you can see this is a DAG I built, and the number is the size. And we will optimize, improve the user experience here. And if you click the leaf node, you can see the order, the offset, and the size. So the size of the block, the offset in the original file. So by using these metadata, so the file store might you to fetch the bytes from the file when user requests it. And it doesn't show the file path in this graph, but here you can see the file information. So the CID, the file size, and the path. There's no links on this node. Oh, so we didn't add the links to the other nodes as well, the intermediate nodes. This is something we can improve. More importantly here, this is the CID information. So this is CID, and we decode and show the base version codec and the multi-hash, including the SHA-2, 256, the hash function, and including the digest. So this is the DAG. And okay, let me add a much bigger file. So this is a segment I split from the original wiki archive. So it's about, let me see, 100 megabytes. Okay, let's go back to the page for indexes. What's the name? CI. Okay. So this is a wiki latest abstract CI. So this is the file I just added. So if you click, so don't surprise that you are not going to see all the details. We are still improving the UI, the user experience. There are too many nodes, blocks. So if you expand, you should go to see something there. And if you click the block, you can see the metadata and the file information and the CID, all the details here. Okay, so to be honest, so this is the size I just tested, and the IPFS-sync accept. So we are still improving the performance, and the size above that may crash the process as there's some file read implementation problem, so that it seems like the file is loaded into the memory at once. So we are still fixing the issue. About that, and we also add some useful links to this menu item IPFS lore and the setting. So this is the IPFSwatch setting, but it's not fully implemented yet. So as I just show you, so we pass a watch directory in the command line interface, and there are some other options we are going to support. This is also already supported in command line, so no copy option. This is the front end. And let me go back to the slides. Okay, so the plan, first of all, is that we want to also watch HTTP resources. In this case, we can use the URL store feature, which also experimental, I think, for now. This is something we also can take care of. The other thing is the file store data storage optimization. So you know that the data will be chunked, and it means that there will be massive files stored in the file system, especially in the big data collection. So that's something will slow down or impact the performance. So we are planning to provide a solution with the distributed key value database. So in this way, we can optimize. It's similar in the pinner data storage. As we add files to the node, the pin set will be expanding. So in this way, if we look into the implementation, the pinner is also loading the data in the startup. So it will also impact the performance and exhaust a huge amount of computing resource. This is also we are trying to optimize. And that's it. Next, contributors. So thanks to Abel, Ben, Chopping, Zhang Xiang, William Mi, Tao Shenxi for their contributions to this demo. So everybody has worked hard to make it. So we show some of our product and our future plan. Thanks. So I know the QA will be moved to the Slack. Thanks. 谢谢.
Perfect. All right. Thank you so much. So it looks like our final demo today will be from PegaSys. And also just a reminder for everyone to keep a lookout in the Slack. There were a couple questions there that are going to be asked, I believe asynchronously soon. So make sure you look there. And just a quick reminder that these demo days are every 2 weeks. So the next one will be August 4th. So keep that on your calendar to make sure you're able to come and take a look at that as well. Okay. So last but not least, we have PegaSys with their demo. I believe I'm pronouncing it correctly.
Hello. So today we will demonstrate our POC2 demo. It was achieved 2 weeks ago, but we missed the demo. So we have recorded a video, but now we will be able to make the demo live. It's about how to retrieve offers so on the secondary market in order, in the next step, to retrieve a file linked to this offer. At the end, we will have a little talk about what will be the next plan. So now I will just demonstrate you how we will be able to get offer from our services. So on the top left, we have Docker service launched with a lot of gateway who are running, a provider and a Lotus node. On the bottom, we have a front end that we will demonstrate at the end. And for other services, we have a gateway, a provider, and a client. All three services have started. I just need to init them. So we have a register mechanism, which means that the gateways and the provider need to be registered in order to discover each other. Also, like the client needs to get registered the gateway to be allowed to communicate with it. So first, I will register all the gateway, and I will register also the provider. Now we can see that each gateway has an identifier, and also the provider has an identifier. I will first publish a DHT offer. So I will use his IDs. And for the sake of the example, currently there are no real file linked to that. It is part of the next step. So I will use a temp CID. What happened is an offer has been published in the system, and now we will try to retrieve it from the client. So we will take this gateway. First, the clients need to add an active gateway to his list of gateways. And then he will be able to use this gateway to reach the provider to get the offer. So it is a DHT offer. So we'll use the DHT command line to find it. So we specify the gateway and we specify the file we want to reach. What we see is that it's a log, but we will successfully get the offer in a few seconds. It takes a little bit of time. Because it needs to make some transaction in order to enable the payment channel. So we get the offers back. Now it is from a DHT mechanism that is a kind of a search mechanism, but we have a more straightforward mechanism to publish offer, which we are calling is publish standard offer. So we have a random mechanism to make the demo quick. We have published 3 random files in an offer that we will try to reach from the client. So I will go back to the client. I will just try to find the offer. Again, from the gateway, I have subscribed, and I will take this file, for example. Oh, sorry. I don't need it. So we are able to get also the offer. One last step. So everything is with a Go client, and we have also built a JavaScript library to do it. So the interface is quite light. It's quite straightforward, but it was just to validate that the JavaScript part was OK. So what I will do the same thing. This is the JavaScript client. So first, I will specify a gateway, and I will specify one of the file I was looking after. So if I try to find the offer, it is just the standard offer, not the DHT. I'm able also to get the offer. That is for the demo. Now we will have a little talk about what we'll do, what we have achieved since this demo for the past 2 weeks, and what we will do for the next demo. So Chen Yang, if you want to take.
Yeah, sure. Yeah, sure. Well, I guess there's another update, like a big update from us. So which unfortunately we couldn't fit in today's demo, is that in past few weeks we have spent time sort of rebuilding some of the components of the system. And so our latest man is having quite a lot of big changes from what we demoed today. Excuse me. So I guess the first thing is that we have already made the switch to P2P in latest man. Second thing is that we have now switched to use the Go CID implementation. So it now works with real world content ID rather than 32 bytes placeholder. And we've also got a working simple data retrieval from offers. So you got offers and you can retrieve content based on the offers you found earlier. And publishing offers from real files and a more complete CLI together with many other interesting features, and of which we have to demo next time, which is a pity. But yeah, because it will take some time to prepare. Yeah, I guess that's all I wanted to say.
All right, wonderful. Well, that does it for today's speakers, it looks like. Remember, the next demo days will be on August 4th, so please sign up beforehand on the document that gets sent out a couple days beforehand. Again, if anyone wants to take a look at any of these recordings, I will be uploading it to the Google Drive shortly, as well as be able to take a look at any questions that were asked on the Slack channel. So Thank you again for coming, everybody. We really appreciate it, and I hope you have a good rest of your day.